try to solve another Leetcode problem, 135 candy. So there are n children standing in a line. Each children is assigned a reading value given in the integer array readings. So inside the readings, so there will be the values. Yeah, so the numbers will be starting from, let's check the numbers. So the readings will be starting from 0 to 2 to the 2 times 10 to the power of 4. And it is a non-negative numbers for the readings. And you are giving candies to these children subjected to the following requirement. So there are two requirements. So the first requirement is each child must have at least one candy. Yeah, so no matter what reading for each child is, but they should have at least one candy for each child. Yeah, this is the first condition. So the second condition is children with a higher reading get more candies than their neighbors. So for example, so these children have a higher reading than its neighbors. Its neighbor is 0, so the reading, let's just copy this array to analyze the problem. Yeah, so for example, for these children, the reading is 1, it's bigger than its neighbors. Yeah, so if its neighbors should at least have a value of 1. Yeah, so for these children should have 2. Yeah, and then we can check another neighbor. So this neighbor, this 2, is bigger than this 0, so it will have a value of 2. So this is why the result is 5. Yeah, but exactly how can we calculate it easily? Yeah, so the brute force is we're gonna check it one by one. So so the brute force is we're gonna use a loop to find the minimum value. So the minimum value would be set to 1, and then we're gonna use another loop to check if the values is not the minimum. If it is bigger than the minimum, we're gonna increase the value, but there will be at least n loops times n, so it will be O(n) square. It cannot pass normally for the Leetcode. Yeah, but for our problem is no matter which children, it always meet the conditions. So for the reading, for example, if this reading is 0 in the middle, so if it is smaller than the left side and also smaller than the right side, so this children should have the least candies. Yeah, should at least have 1. Yeah, but for this right side, for example, this 2, it is bigger than its neighbor's 0, so it should be increased by 1. And similarly for this one, if it is bigger than its neighbors, it should also increase by 1. Yeah, but how should we solve such problem easily? We can use 2 loops to solve it easily, and both loops would solve from the left side and the right side. So for the left side, we're gonna use 1 loop to check if the value, for example, if the second value is bigger than the first, so we're gonna increase by 1. So from the beginning, the readings should always start from 0, from 1. Yeah, because each children should at least have 1 caddy. Yeah. Now from the left to the right side, we're gonna check the second children. It is smaller, we're gonna not update it, and then we're gonna check the next. If this is a 2, 2 is bigger than its neighbor, so it will be updated to 2. Yeah. So this will be from the left to the right side. Yeah, now let's check from the right side to the left side. So from the right side to the left side, we're gonna first check the 0, the second children. If it is bigger than its neighbors from the right side, 0 is not bigger than 2, so for the 0, it's gonna still be 1. Now we're gonna check the first children. If it is bigger than the right side, no, it is not. Yeah, 1 is bigger than 0. Yeah, so this one is bigger than the right side. So this, yeah, let me write it here. So for the first one, it is a 0. The second one, it is a smaller. It is a still. The first one is 1. The second is smaller than 2. So it is still 1. So for this children, for the right side, its neighbors, it is bigger than 0. So it's gonna be updated to 2. Yeah. Now, the final result, we just need to check the maximum of the left side array and the right side array and get the final result. We need to sum the maximum of all those values. Yeah. Now let's try to code it. Use two loops. So the first loop, we're gonna check the left array, and the second loop will be the right array. Yeah, let's prepare a variable n would be the length of the readings. Yeah, now let's prepare a left side array and the right side array. So it's gonna be 1 times n and 1 times n. Yeah, so this is preparation for the left and right because it should at least have one caddy for each child. Now we just need to loop through the left and the right. So for I in range from the left side, we're gonna start from the second child. So it's gonna be 1 to n. Yeah, we're gonna check if readings of I more than the left side. So it should be the readings of I minus 1. So we're gonna update the left array. So from the left side, left I should equal to the left I minus 1 plus 1. So this is from the left side. Similarly, we just need to copy it and change it to the right side. Now let's put it to the right side. And gonna be for I in range n minus 2 and minus 1 and minus 1. Yeah, so for this one, we're just gonna check from the right to the left. So the reading, if the reading I is more than its neighbor from the right side, so I plus 1. So now we can update the right array should be equal to right I minus 1 plus 1. Yeah, should be right I plus 1 and then plus 1. Yeah, this is for its right side. So the final result, we just need to sum of the maximum of the right to the left. So maximum AB, so for AB in zip, left and right. Now let me just run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it passed all the testing cases, and the time complexity is O(n) because we just use the 2 for loops. And this problem is really difficult to think about, so that is why we have to practice the greedy problems. So there's basically no patterns for you to remember everything. So for each problem, if you think about it, it's bigger than the neighbors, so from the left side it meets the conditions, and if it also from the right side it meets the conditions. Yeah, so for each number, both from the left and the right side, it always meets the conditions. And what is the greedy idea? So the greedy idea is we take the maximum. Yeah, because if a smaller value meets the conditions for left and right, if we choose the maximum, it means this number will always meet the conditions. For example, this 0 will always be smaller than this 1 and always be smaller than the 2. Yeah, and for each number, it always meets the conditions. And we check the sum of the maximum of both left and right. Then we got the result. Thank you for watching. See you next time.